Welcome to CW 5.6. To start, we're going to try this advanced problem right here. Notice already that this is a log equation, but the bases are different. So to do this problem, there's actually a secret property we're going to talk about today. The log base a of b is actually equal to log base a to the n, b to the n. So make a box for that. This is a very helpful property. And essentially it's saying that you can raise the base to a power as long as you raise the inside part to a power. So if you look at these two, look at these two. So if we look back at the question here, what I'm going to do is raise 2 to the power of 2, because then I'll make it 4. And I'm also going to raise 3x minus 1 to the power of 2. So again, by doing this, look at what happens. Now it's like a regular log problem that we've been doing. Let's put it together. Notice it's subtraction, which means we're going to divide. And now I can put it into exponential form. So 4 squared is going to equal 9x squared minus 6x plus 1. And that's going to be divided by x plus 1. So let's multiply by x plus 1. So 16x plus 16 should equal 9x squared minus 6x plus 1. So 0 should equal 9x squared minus 22x minus 15. And let's factor that over here. So that's going to be 3x and 3x. Let's try 5 and 3. Okay, we can see that doesn't work. So maybe we try 9 and 1. And look at that. That does work, because now I'm going to make my 27 right here. 3 times 9. And 5 is 1 times 5. So x should equal 3, or negative 5 over 9. Now we look back at the question. I can see that if I plug in negative 5 over 9 right here to this one, that creates a negative number. So that means that one doesn't work. So x equals 3 is our only answer. Okay, so that's our first advanced problem today. Let's look at a couple other ones. So review 1. True or false? If false, fix it. So this is clearly false. A couple ways to fix this. If you look on the left side, we cross this out. If you subtract logs, what happens is only the insides divide like that. So that's probably the easiest way to fix that. I could also fix the right side and say log x over log y, that's equal to log base y of x. Okay, look at number 2. I can see it's adding to multiply, so 2 is true, that's fine. 3, that's pretty close. For a domain of a log, the inside should be greater than 0. So if you imagine x squared is greater than 0, that's almost all real numbers. X cannot be 0, which means 3 is actually false. And then 4, this is definitely false. We do a couple things here. You could hairball, or we could move that 2 down here using the power rule. Log base 5x, like that. That could be equal to log base 5x squared. So that's one way to fix it. Or we could write this as log base 5x quantity squared. So those are some common misconceptions of logs. Let's go to number 2. Describe the transformation from f to g. So to help you, I'm going to label this. This one's f and this one's g. So just by looking at this, I can actually see that f to g went up 2. Now that might seem weird because look at this. If I were to purely ask you what happened, you would normally say x times 1 over 100, right? This would be the stretch that happens. But we can clearly see there's a shift going on. So what happened? So what we can actually do is describe this using a shift rather than a stretch. We're going to take g and think of it as log 100 plus log of x, and this is going to be 2 plus log x, which explains why it went up 2. So for the same thing, let's look at b. If I ask you to describe what's happening using a stretch, and again, this is f and this is g, we would say f to g, it would be x times 1 over 27. But if I wanted to use a shift, we could say log 3, 27, plus log base 3x. This is 3, so it must be up 3. Okay, 2 more. Review 3. Use properties of logs to simplify each expression. So for this one, a couple things we can do. Let's separate this. Log base of a third of 9 plus log base of a third is x. So at first glance, it looks like this is pretty much all you can do, but we actually can go a little bit further. So let's put a line here. This thing right here, if you just think about it, this is saying 1/3 to what power makes 9? And that number would be -2. So I can write that as -2 plus log base 1/3 x. And you could leave it like that, but I'm actually going to show you, you could go a little bit further, because we can think of this log base 1/3 x as log x over log 1/3. And let's think of that 1/3 as 3 to the -1, and that -1 has the power to move down. So really it becomes this, negative log x over log 3. So we did all that work to say, another way to write this is -2 minus log base 3x. So you're probably thinking, like, is there an easier way to remember this? Yes, there's another property that we can write. We can write log base ax, or base a of x, is equal to negative log base 1 over a x. And you're seeing that right here. Notice how this 1 over 3 became 3, and you just negate the sign. Okay, number 2. Number 2 is kind of a more standard one. Now we can just separate it. So this would be 3 plus 2 log base 3x. That was not too bad. Let's go to our last one. Find the inverse. So for this problem, recall to find the inverse, you got to switch x and y. So x will equal 3 minus log base 2 y. And let's kind of move it around. Log base 2 of y should equal 3 minus x. So 2 to the 3 minus x should equal y. So here's my inverse function. 2 to the 3 minus x. Now this is saying find f inverse of b. So all we're going to do is plug in b. 2 to the 3 minus b. And we're done.